Alright. A blank is a set of ordered pairs. That's going to be called a relation. And again, these may or may not be on your quiz on Friday. So a relation is a set of ordered pairs. The domain is going to be the set of x coordinates. And your range is going to be the set of y coordinates. Do y'all remember that from Algebra 1?
Yeah.
Okay. A function, which is what we're going to be talking about today, a function is a relation in which each element of the domain, so every x in your ordered pairs, is paired with exactly one element of the range. So, for example, you couldn't have 2, 1 and 2, 4 because we have the same x value, right? But it has two different y values, so it's not a function here. You can't have one x value going to two different y values. Does that make sense?
Would it still work if it was like a -1?
If this was -1,
And like the other one was 1?
this one,
No, it was like
this one.
4 was a 1.
It doesn't matter about your y values. It's just your x value. You can't have the same x value for two different y values. Like, for example, Guy, you could have 4, 1 and 3, 1 because you have two different x values going to whatever y values. But you couldn't have 3, 1 and 3, 1 or 3, 1 and 3, 2. Does that make sense? Yes?
Well, I mean, I was asking if it was like 4, 1 and 4 -1. Is that low?
Yeah, that couldn't work because you have same x value going to two different y values. Alright. There's three different types of functions, or actually two. The first one is one-to-one, and that means each element of the domain, so everything in here, goes to exactly one unique element of the range. Okay? An onto function means that everything in the range has an x value. There's no blank one like this one. That means onto. And then if it's both one-to-one and onto, each element of the domain will go to 1 in the range. Each one will have a separate value to go to. So the first thing we're going to do in 1 and 2 is talk about domain and range first, and then we'll worry if it's a function or not. Alright, so domain again is what values? X. Yeah, the x coordinates, so the x values. So tell me which ones are the x values in here, just say them out loud.
-6, -5, -3, -3. Oh, wait, -1.
Good. When we put these, list them as our domain, you need to write them in order from least to greatest on the quiz. So which one's the smallest? Next. And they won't always be in order like this. It just happens to be in this one. Did you check in? Alright, you'll need to go check in. Alright, for the range, same thing, the y values, but you'll need to put them in order. So here's our y values. I'll circle them. Which one's the smallest?
-9, 9, and -9.
Okay, do we have to write them twice? No. So in the range, if you have like two y values that are -9, you don't have to write it twice. So what would the next one be?
-7.
Next. -1. Next. 7. Good. So that's how you list your domain and range. You just listen from least to greatest. Don't write it if it's repeating. Like, you don't have to write it twice. Alright, next we're going to set up a chart kind of like this up here. And that's going to make it easier for us to determine if it's one-to-one or onto. So I'm going to write all my domain over here. -6, -5, -3, -1, 6. And the range over here. -9, -7, -1, 7. And now we're just going to draw lines connecting to what is its y value. So what is -6's y value?
-1.
Good. So I will make a line connecting them. What about -5?
-9.
And then -3 goes to -7. -1 goes to 7.
6,
And 6 goes to -9. Very good. Alright, so here's where we check whether it's a function, one-to-one, and onto. Okay. To be a function, remember I told you up here that two x values, or one x value, can't go to two different numbers, right? That can't happen. So are there any x values in here that are going to a different number?
Is that
No single x value going to multiple y.
Yes. So the easiest way to check if it's a function, look at all these lines. Are there 2 coming from any x value?
No.
No. So this is a function. Again, you just look at your x values, your domain. Is there 2 lines coming from any of them? Nope. I mean like this. It would look like that if there was 2 lines. Alright, 1-to-1 function. Each element of the domain pairs to exactly one unique element of the range. So is that true?
No.
Why? What makes that not true?
Because there's 2 x values on the one.
Good. The -5 and the 6 are both going to -9. And let me do it like this. -9 is going to 2 different x values. -5 and 6. So if you have 2 lines coming from a y value, which you do, -9, right? This is not 1-to-1. So again, you look at your y values. There's 2 coming from the -9, so it's not 1-to-1. And the onto, you just make sure that every value in your range has an x value. So in other words, if there was a 0 right here and it didn't have anywhere to go, it was just right there, it didn't have an x value, then this would not be onto. But see how every value in the range has somewhere to go? So this is onto. So it's a function and it's onto. And we are done. That's it.
I feel like it's going to get hard.
Any questions on that one? Yes. On the on which one?
On the domain.
On the range? This is -1. So if you look at the number line, anything to the left is 0. So the further away from 0 you get on the left side, the smaller it'll get. So with negative numbers, it's kind of the opposite. The biggest negative number, which is -9, is actually the smallest. Then -7, then -1. So the further you get away from 0 to the left side, the smaller it gets. The further right you get, the bigger it gets. Alright, next one. Somebody tell me the domain listed correctly.
-2, -1.
Good. We don't have to have repeating values. Smallest one up here is the -2, then -1, then 2. Yes.
This is like on our test or something like that.
Mhm.
Can we just jump to the vertical part of it? So
It'll say list the domain and range, so you'll have to do this. Somebody tell me the range in order. Good. And now we can set up our chart. So we'll have -2, -1, 2, -2, -1, 0, 1, 2. Alright, where's the -2 going to? 0. Good. The -1. Where? And 1. Alright, where's the 2 going?
2 and
Good.
-2.
Alright, so the first thing we're looking at, is it a function? Why? Good. You look at the domain, see how it's got 2 coming from -1, 2 coming from 2? So it's not a function. And if it's not a function, you don't even have to list if it's 1-to-1 or onto. If it's not a function, you can stop there. Because to be 1-to-1 or onto, it has to be a function. Any questions about that one? Alright, flip it. What now? They're in. Alright. This one they've already done the chart for you, so all we have to list is domain and range, then tell if it's a function onto 1-to-1. So the domain would be what? Nope. Good. Good. Gotta list them in order. What about the range? Good. Alright, can somebody tell me if this is a function or not? Yes, Eric.
No.
Why?
Because there's one number going to, two numbers going to one.
Yes, on the domain. I get what you're saying. So the 8 is going to -4 and 14, right? So it's not a function. Very good. Questions about that? Alright. Levi, tell me what the domain would be for this one.
-3, -2, -1, 0, 1.
Good. And the range is already listed in order as well, right? 0, 2, 4, 6, 8.
They're not always going to be in order, are
Nope, this one wasn't.
they? Oh, yeah.
Alright, is this one a function?
Yeah, what do we have to put in the order?
Yes.
Yeah, you have to just write them out.
No, it's not.
Yes or no?
No. There's two X's on one line. Yes, there is.
No, it isn't.
If it's a function, that means that one x value can't go to two y values. So the easiest way, you just look at the domain for a function. Is there two lines coming out of any of them?
No.
No, so it is a function. Alright, now for 1 to 1,
Is it? Yes.
you look at the y values. Is there any two lines coming out of one of the y values? Yes, there's two lines coming from what? 6, right? 6 is going to which two values? -1 and 1. So 6 is going to -1 and 1, so it's not 1 to 1. Alright, on to just means that every value in the range has somewhere to go. Is that true in this case? No, which one's left out? The 8 has nowhere to go, so this is not onto. So it's just a function, but it's not 1 to 1, and it's not onto. So domain is when you look at with function, you look at the domain. With 1 to 1, you look at the range. With onto, you're looking for anything left out in the range. Any questions on those? Okay, the next thing we're going to talk about is the vertical line test. So sometimes you might be given a graph like this, and it's going to ask you, is it a function? But this one, it doesn't have any coordinate points, right? So there's two ways you can check this for a function. But the easiest way is a vertical line test. Has anybody ever heard of that? Yes? Alright, what's the vertical line test? Just give me an easy explanation.
If it touches 2 points at the same time, it doesn't work.
2 points on what?
On the curve. On the line.
Yeah,
On the curved line.
the curved line, if the straight line touches 2 points,
So which one's not a function?
the second one.
The right side is not a function.
Alright, have y'all ever talked about the vertical line test with your pencil? Using your pencil?
No.
Yeah.
Yes? Okay. So you just take your pencil and have it vertical line test, and if it touches your pencil in two places anywhere across the graph when you move it across, then it's not a function. So on this one, it never touches my pen twice, right? Always touches my pen in one place. And this one, does it touch it twice?
Yes.
Yeah, it touches it right here and right here, so it's not a function. So that's an easy way, using your pencil.
Not a vertical line.
So this one, it passes the vertical line test. This one, it does not. And like Guy said, this x value is 1, right? Right here. Notice how it has two different y values. This one has a y value of maybe 1. This one has a y value of -2. So if you have one x value going to two different y values, just like up here, it's not a function. Does that make sense? -2 and 1. Alright, so looking at number 5, using the vertical line test, would this be a function?
No.
Why?
But that's from 2 different points.
Good. So if you move my pen through this, when does it touch my pen at two places? Right here. At 1, 5, and 1, 2. And it's because we have the same x value at two different y values. So this is not a function. Alright, we feel good about determining whether it's a function, 1 to 1 on 2. Everybody's good with that? Yes? Okay. Alright, next one. Evaluate a function. And y'all know how to do this, so this is just going to be a little bit of review. When it says find each value if f of x equals 3x minus 5, g of x equals x squared minus 2x, and it gives us f of -3, what is it really asking us to do?
Plug in
Salt.
the,
Plug in the salt.
Plug in what?
3,
Negative
-3, 4,
X.
and which one?
The equation on top.
There's two of them.
The instruction.
the
Oh.
F of x, good, because it has an F in the original. So instead of 3x minus 5, we're going to put 3,
Negative 3.
-3 minus 5. And from here, we just do order of operations. That's going to be what?
Negative 14.
Negative
Negative 9.
minus 5, which is
Negative 14.
good. All right, try 2 on your own, and then I'll call on somebody. Everybody done with that one? Anybody want to tell me how to work it? Go ahead.
You plug in the 4 for x, you get 4 squared is 16 minus 8.
Huh?
Or, well, 2 times 4,
Okay.
and you get it 16 minus 8, and you get it 8.
Very good. Any questions on that one? You did 4 squared minus 2. Oh, the 4 goes into both places for this x. So it'd be 4 squared minus 2, and then you got to plug this 4 in for this x as well. Any other questions on that one? All right, what's different about 3 and 4? They have letters instead, okay? So let's do 4 together, then I'll let you do 3 on your own. Which function are we plugging this into? G of x, and we're plugging in what for x? 5n. So tell me how to set this up. All right, good. Now we just simplify. What is the squared going with? The 5, the n, the 5n, what?
5.
So both of them?
Yeah.
So tell me what both of them would be squared then.
25.
Good. 5 squared is 25. N squared is just n squared. This would be minus
Negative.
10n. Very good. So when I subtract them, I'll get 15n? Why? Why are they not like terms? Good. Different exponents. So we leave it. Do 3 on your own. Then I'll call on somebody. All right, Austin, what'd you get for your answer? Justin, what'd you get for your answer?
3a minus 5.
Good. Any questions about how we got that? You just plug in, this one's asking us to plug in what for x? A. So you put 3, and instead of x, we'll put a minus 5. And then just multiply those together, you'll just get 3a. Can't subtract them because they're not like terms. Any questions on evaluating functions? Alright, flip it. I want you to do these on your own. You can pick one that we'll do together. I'm guessing one of the fraction ones? 7? Okay. We're plugging into which one? F of x, which is 3x plus 2, correct? So tell me how to rewrite this.
3 and 1/3 plus 2.
Alright, remember the trick I taught you about multiplying fractions? When they have 1 as your denominator. What could you do from here? Cancel what out? The 3's. Good, because 3 divided by 3 is going to be what? Just 1, right? Any questions about that?
You get 3.
So 1 plus 2 would give you 3. Very good. Alright, you are going to do these on your own. And then I'll have 1, 2, 3, 4 people to come up on the board and work them. Let me know if you need help. Let me know if you want to check your answers. Yes. Yeah. Give me just a second. It's not 16 minus negative 8. The minus, if you want to treat it as a minus sign, then you want to treat this 2 as a positive. Does that make sense? This one was already had a 3 outside, and the one side I just brought down, so I didn't have to flip it. All I had to do was cross the 5. So 3 divided by 3. And then 1 times 1. If you're still working, that's fine. Raise your hand if you can tell me what you got for number 5. Anybody else got anything different?
Got 72.
I got 144.
Okay, one person that got 144, come working on the board. Alonda, if you'll work yours on the board.
Yes, ma'am.
Negative 72.
Feel like that's wrong.
That's what I got on it.
Okay, I'll make it. Yeah, hey, you wrong. You might not be, 'cause I got this.
You gotta show your work.
Oh, see, I see you calculating.
Anybody can show their work on this? Come on, somebody else. Just show your work in between this. Not yet. Wait till we get done with this. Can you just show them one more? Actually, you can use my sink back here.
There's the cartridge.
Okay.
Stand on. Stand on.
Thank you. Alright, let's look at this one first, okay? How did she get 12 squared right here? Multiplied what? Okay, let's review order of operations, okay?
Exponents.
Exponent goes first. So could we multiply and then use the exponent?
No.
No, we'd have to do the exponent first, which is what happened right here, and then multiply, right? Okay, see? So, negative 6 squared, we know is negative 6 times negative 6, right? Did anybody get a negative 36? Okay. Remember, your calculator will lie to you. You do put parentheses, but it should be parentheses, negative 6, parentheses squared on the outside. So this would give us positive 36, negative 2, so it is negative 72. Any questions on that one? Alright, raise your hand if you can tell me your answer for number 6.
Negative 37.
Negative 37, anybody get anything different?
I got negative 1.
What now?
I got negative 1.
Okay, you'll work yours up here, and somebody who wants to work negative 37, whoever got that, come on up.
I got that one.
You have to show your work.
Here's the phenomenon.
Oh, we are?
Negative, 7 or 6, you said.
Number 6.
We can split it.
I'm right here.